Okay guys, today we're going to talk about compound inequalities. Now compound inequalities are when we're dealing with kind of two inequalities at once. So on number 1, we have b is greater than -1 and b is less than or equal to 3. So compound inequality will be joined by either the word and or. So there are two different types of compound inequalities. Today we're only going to be focusing on and inequalities. So this is saying I need some number that's greater than -1 and at the same time I need a number that's less than or equal to 3. So what we're going to do is we're going to come up with all possible numbers that could meet that criteria. And to do this, first we're going to graph it. But when we graph it, we're going to graph it a little bit different. We're going to start with what's called starter graphs or helper graphs. So if I were to graph b is greater than -1, it would be an open dot over -1 with an arrow going to the right. So we're going to graph a starter graph of b is greater than -1 above our number line. We don't want to put it on it yet, so b is greater than -1. Here's -1, so above it I want to put an open dot with an arrow going to the right. Now we're going to do the same thing with b is less than or equal to +3. So I'm going to find +3 and go above it, and we're going to start with a closed dot. Well, if it would let me make a closed dot, with an arrow going to the left. So these are our two helper graphs. These helper graphs portray these two inequalities separately. Now since this is an and inequality, we have the word and, my final graph is where these two graphs overlap. So notice these two graphs, if I were to read them from left to right, start overlapping right here at this open dot with the -1. And they overlap in all of this space, and they stop overlapping when they get to +3 with the closed dot. So just that space of where they're overlapping is what I want to graph. So on my actual graph, I'm going to start graphing with the open dot over -1, and I'm going to stop on +3 with a closed dot. Then I just fill in between. So there's no arrows showing that this goes on forever and ever like we did in the past one. These are the numbers that are true with this statement. So I need a number that's greater than -1 and at the same time less than or equal to 3. Notice -1 has an open dot. So if I were to actually choose -1, it wouldn't meet the criteria because it's not greater than -1. Now if I were to choose the number 2, for example, that is greater than -1 and at the same time it's also less than or equal to 3, so it works. If I were to choose the number 4, it is greater than -1, but it's not less than or equal to 3, so it has to make both of our statements true to work. Now finally, I just need to write my answer in set builder notation. So this is going to be a little bit different than what we are used to. We're going to start with just the same thing, the set of all b's, because that's the variable we're using, such that now when we have an and inequality, a compound inequality that starts and stops, our answer is actually going to kind of look like number 2. So here's how we do this. We're going to start with the smallest number that's included on our graph. So the smallest number is -1. Then we're going to end, so we're going to skip this middle stuff for a while. We're going to end with the last number that's included on my graph, which in this case is 3. In the middle, we're going to have our variable and some signs. So let's go ahead and start with the variable. So my variable is b, so that's going to go in the middle. Now when we write our and compound inequality statement, our symbols will always point to the left. So that means we can either use less than or less than or equal to. When writing and inequalities, you will not use greater than and you will not use greater than or equal to. They must always, always, always point to the left. So to determine which one we use, we just look at our dots. So on -1, since it is an open dot, we're going to use less than. On +3, since it's a closed dot, we'll use less than or equal to. And then we just close our set brackets. So our answer reads like this: the set of all b's such that, and we do not read it left to right. Instead, we start with the variable and say b is greater than -1 and b is less than or equal to 3. Now on number 2, they gave it to us exactly like we just wrote it. Now what this actually means, this is an AND statement, we can break it up into two small inequalities. So our first inequality is just going to be this guy right here, the variable and whatever's to the left, -2, which is less than or equal to q. And since they're combined like that, I know that the word that has to come after it is and. Then my second inequality is the variable and everything that comes after it. Q is less than or equal to 1. Now if I were to look at this, this one on the left doesn't read nicely because we like our variable to come first. So let's switch that around quick. Instead of -2 is less than or equal to q, I want the q to come first. I'm going to put that in a different color. I want the q to come first, and I want the -2 to come second. But be careful with your symbol. Your symbol still has to point to the same term. So notice here that my symbol is pointing, like a little arrow, to the -2. In my rewrite, it still has to point to the -2. So q is greater than or equal to -2. So if you were asked to, that's all you'd have to do, is you'd have to split it into your two inequalities. But they didn't really ask us to do that. We're just kind of talking about that so we understand what it's saying. To graph it, when they give it to you like this, it's actually very, very easy. All you have to do is you start with your starting point, you end with your ending point, and you go with your dots. So my starting point is -2. Now pay attention to the symbol that comes in between the -2 and the q. It is less than or equal to, so that's going to be a closed dot on -2. Then we're going to end on +1. Again, this is going to be a closed dot because it's less than or equal to. So closed dot on -1. And then since it's an and inequality, we just fill in between. Finally, we write it in set builder notation. So the set of all q's such that, now we just need to describe our graph like so. So you start with your starting point, which is -2. You end with the biggest number, which is 1. And the q goes in between. Now remember, the symbols will always point left, so you're either going to use less than or equal to. So over the -2, since it's a closed dot, we're going to use less than or equal to. And over the +1, since it's a closed dot, we're also going to use less than or equal to. Now again, to read this, it reads the set of all q's such that q is greater than or equal to -2 and q is less than or equal to 1. Just like we have it up here, q is greater than or equal to -2 and q is less than or equal to 1. So on number 3, I have -3 is less than d and d is less than 2. So we're going to have to use starter graphs on this one because the word and is written clearly. But we can't graph this guy until the variable comes first. So I want the d to go first, and I want the -3 to go second. But be careful because the symbol still has to point to the same term. Here my sign is pointing towards the -3, so my new sign still has to point towards the -3. d is greater than -3 and d is less than 2. Now we can go with our starter graphs. So my starter graph of d is greater than -3. So find -3, and above it, don't go on the number line, above it we're going to go an open dot with an arrow going to the right. Now d is less than 2, so this starter graph is going to be above 2 with an open dot and an arrow going to the left because those are the numbers less than 2. Now, since this is an and inequality, I want where these two graphs overlap. So notice they start overlapping at -3 with that open dot, and they stop overlapping at 2 with that open dot. So just this area where they overlap is what I'm going to put on my graph. So I'm going to start with the open dot on -3, and I'm going to end with the open dot on 2, and we fill in what's in between. Now, the helper graphs, don't get used to just going ahead and graphing on the number line. The helper graphs are very important. I grade for those. Now we just write our answer in set builder notation. So the set of all d's such that, and again, to write this in set builder notation, start with the lowest number, so -3, end with the biggest number, 2. The variable goes in the middle, d, and our symbols must always point to the left. So we're either going to use less than or less than or equal to. Since these are both open dots, both of my symbols will be less than. Now again, to read this, we read it just like we have it up here. The set of all d's such that d is greater than -3 and d is less than 2. On number 4, we have x is greater than -2 and x is greater than 1. Both of these are written so that my variables come first, which is awesome. So we just start with our starter graphs. X is greater than -2. So -2, we're going to have an open dot with an arrow going to the right. X is greater than 1. So an open dot over 1 with an arrow going to the right. Now, since this is an and inequality, I want where the two graphs overlap. So they start overlapping here at 1, and if I follow where they're overlapping, notice if I'm highlighting where they're overlapping, I ended up highlighting both of those arrows. That means they keep going in the same direction. They're not going opposite directions like 1, 2, and 3. Since they're going the same directions, they never stop overlapping. So if I want to graph where they're overlapping, I'm going to come down to my number line, and I'm going to put an open dot over 1 because that's where they started. And then I'm going to follow the highlight, and I end on an arrow, so I'm going to have to draw an arrow. That means that all of the numbers greater than 1 will suffice. Now, let's find out why that is. I want to choose a number that's greater than -2 and at the same time greater than 1. So if I were to choose the number 3, that is greater than -2, and it's also greater than 1, because any number that's greater than 1 is already greater than -2. So to write this in set builder notation, we start with the set of all x's such that. Now, to describe this, it's just like we have been in the past. It doesn't have a starting point or a stopping point, so we don't have to do like 1, 2, and 3. We just describe it as x is greater than 1. So here's the problem, here's the solution. The problem was I need a number that's greater than -2 and greater than 1, and my solution is any number greater than 1 works. Let's try it on number 5. On number 5, 3 is greater than d and d is less than or equal to -2. This doesn't work because I need the variable first. So we're going to come first and say d and 3, switch those spots. Notice the symbol is pointing towards the d, so the symbol still needs to be pointing towards the d. So 3 is greater than d is really d is less than 3. So let's graph our helper graph. D is less than 3 is an open dot over 3 with an arrow going to the left. Then d is less than or equal to -2. So -2, we're going to have a closed dot over -2, and since it's less than or equal to, we're going to go to the left. Now we highlight where they overlap. So they're overlapping. Notice if I were to go from left to right, they start overlapping with arrows, which means I'm going to start with an arrow, and it's going to stop at that closed dot on -2. So this one's kind of like number 4. So if I were to graph where they overlap, we have an arrow on the left side, and it ends at this -2. So any number that's less than or equal to -2 is already less than 3. So my solution is the set of all d's such that, and then I just describe my graph. D is less than or equal to -2. On number 6, D is greater than 3 and D is less than -1. So let's graph our helper graphs. D is greater than 3 is going to be an open dot over 3 with an arrow going to the right. D is less than -1, so I'm going to go over -1 with an open dot going to the left. Now, I want where they overlap. Now, if you notice, this green one starts and then stops at -1, and this red one starts at 3 and goes the opposite direction. So they don't actually overlap. So since they don't overlap, that means there is no answer. That means that there is not a number that is bigger than 3 and at the same time smaller than -1. So we have no solution. Now, number 7, it says solve each compound inequality, then graph the solution set. Then write the solution in set builder notation. So they gave us compound inequalities. Now I know that this is an AND inequality because it's a lot like number 2. So I want to get this variable on the inside all by itself. And we're going to do this almost exactly like we would solve a normal equation, but there's just a little bit different. So to get this variable by itself, I would need to subtract 3. But we have 2 inequality symbols, which means I not only have to subtract 3 from this 5 over here, I also have to subtract 3 from this 4 over here. So we're going to be subtracting 3 times. Now on the left side, 4 minus 3 is 1. Now I did not multiply or divide by a negative number, so I can bring that inequality symbol straight down. It doesn't change. These 3's cancel out and leave me with W. And again, this symbol doesn't change. And then 5 minus 3 is 2. So I'm left with 1 less than W less than or equal to 2. Now again, that's not how we actually read it. We really read it as W is greater than 1 and W is less than or equal to 2. Now to graph it, since it's like number 2, I don't need helper graphs. I can bring this straight down. So I start with my smallest number, which is a 1, and since it's less than, it can be an open dot. I end with my biggest number, which is 2, and since it's less than or equal to, it's a closed dot. And then I shade in between. Finally, we just write it in set builder notation. So the set of all W's such that, and if you'll notice on number 2, when we wrote our set builder notation, this guy right here ended up being the exact same as this guy right here. So when they give it to you like that, you can just bring it straight down. And voila. On number 8, I want to get P all by itself, so I need to add 5 to get it away from the P. But I have to add it to each side, so plus 5 over here and plus 5 over here. Now, -3 plus 5 gives me a positive 2. 2 plus 5 gives me a 7. I did not multiply or divide by a negative number, so the symbols stay the same, less than or equal to and less than, and we're left with a P. Now again, it's already in that nice and condensed form, so I can bring it straight down. I start at 2 with a closed dot, and I end at 7 with an open dot. Then we fill in between. Finally, we write it in set builder notation. So the set of all P's such that, and it's nice and condensed, so we can just bring it straight down. So again, the set of all P's such that P is greater than or equal to 2 and p is less than 7. On number 9, we have negative 4 less than x plus 2 less than or equal to negative 2. I want to get that x all by itself. So we're going to subtract 2 from each side of our inequality. On the left side, negative 4 minus 2 is negative 6. Bring down my symbol. These 2's cancel out and leave me with x. Bring down my symbol. And negative 2 minus 2 is negative 4. When it's nice and condensed like this, we bring it straight down. So we start at negative 6 with an open dot. We end at negative 4 with a closed dot. And we fill in between. Now we write our set builder notation. And since it's nice and condensed, we just bring it straight down. The set of all x's such that x is greater than negative 6 and x is less than or equal to negative 4. Now on number 10, they did not give it to us nice and condensed. We just have to solve like normal. So we have two inequalities here that we just have to take a second and solve. So y minus 1 is less than 2. I'll add 1 to each side. And we'll be left with y is less than 3. Now over here we have y plus 2 is greater than or equal to 1. So we subtract 2 from each side. And we're left with y is greater than or equal to negative 1. Next, we just draw our helper graph. So if I start with y is less than 3, our helper graph of that would be an open dot over 3 with an arrow going to the left. And y is greater than or equal to negative 1. So I want an open dot over a closed dot over negative 1 with an arrow going to the right. Now since this is an and inequality, I want where these two graphs overlap. So they start overlapping at negative 1, and we've got a closed dot there, and they stop overlapping at 3 with an open dot. Then they overlap in between. Finally, we write it in set builder notation. So the set of all y's such that. Now again, to write this in set builder notation, since it's an and statement, we start with the smallest number, which is negative 1. We end with the biggest number, which is 3, and the variable goes in the middle. So we have a y. Now our symbols always point left, either less than or equal to. Since this first one is a closed dot, we have less than or equal to. And since my second one is an open dot, we have a less than. So the set of all y's such that y is greater than or equal to negative 1 and y is less than 3. What I'd like you to do is pause the video and just solve the two inequalities on 11 by yourself. Then come back and we can graph the helper graphs together. Alright, hopefully when you solved your first inequality, you were left with n is greater than negative 1. And then when you solved your second inequality, you were left with n is less than 2. Now our helper graphs, n is greater than negative 1. It's going to be an open dot over negative 1 with an arrow going to the right. And then n is less than 2, so an open dot over 2 with an arrow going to the left. Now these guys start overlapping at negative 1 and stop overlapping at 2, both with open dots. So negative 1, 2, and they overlap in between. Now we write it in set builder notation. So the set of all n's such that smallest number is negative 1, biggest number is 2, variable in the middle, symbols point left, and since they're both open dots, they're both just less than. So the set of all n's such that n is greater than negative 1 and n is less than 2. On number 12, we have negative 3 is less than 3d plus 12, less than 33. So we just have to get the d by itself. So we need to start by subtracting 12, but remember we subtract it from each side of this inequality. Negative 3 minus 12 is negative 15. The 12's cancel out and leave me with 3d. And 33 minus 12 leaves me with 21. Now, I did not multiply or divide by a negative number, so the symbols stay the same. Then, to get d by itself, we divide each term by a positive 3, and since it's positive, again, the symbols do not change. Negative 15 divided by 3 is negative 5, and then 21 divided by 3 is 7. Now it's all nice and condensed, so we just bring it straight down. I start at negative 5 with an open dot. Oh, now be careful, our scale here goes by 2, so negative 5 is halfway in between negative 4 and negative 6. And it ends at 7, which is halfway between 6 and 8 with an open dot. And then we fill in the space in between. Finally, we write it in set builder notation, so the set of all d's such that, and it's already nice and condensed, so I can bring it straight down. Set of all d's such that d is greater than negative 5 and d is less than 7.